Alrighty. We have number 8. The Maclaurin series for a function f is given by this lovely series, and it converges to f of x for all absolute value of x is less than r, where r is the radius of convergence. So what we're going to be doing here for part A is finding that value of r to tell us the radius of convergence. And part A just says, hey, use the ratio test. So that's what we're going to be doing. So we have the limit as n approaches infinity of the absolute value of -3 to the n minus 1 plus 1, or n, x to the n plus 1, and then n plus 1. Multiply that by your reciprocal. That's going to be n. And then I'm going to have -3 to the n minus 1. Then I'm going to have x to the n. All right, so now I'm going to clean this up a little bit. -3 to the n and -3 to the n minus 1 becomes -3 to the -1. And I'm going to bring that up so that it's just -3 there. The x to the n plus 1 and the x to the n just becomes x. Then I have n and then n plus 1, which I'm more worried about because this is what the limit of n is approaching infinity for this right here. In this case, as n approaches infinity, this limit will become 1. So now I'm just left with the absolute value of -3x. And remember, using the limit, the ratio test, if I want something to converge, it needs to be less than 1. So we have the absolute value of -3x is less than 1. I could technically just move the negative away. So that just becomes the absolute value of 3x is less than 1, which is going to be the absolute value of x is less than 1/3. So that's how we get our radius of convergence being 1/3 right here. So that is r. Oh, well, r is equal to 1/3. All right, B says write the first 4 non-zero terms of the Maclaurin series for f prime. And then we have express f prime as a rational function for the absolute value of x is less than the radius of convergence. All right, so I'm going to do this using term-by-term derivative because they already kind of gave me the first 3 terms. I could easily find the next one. But looking at f prime, this is going to be 1 minus 3x plus 9x squared. Okay, plus something. Well, if I'm looking at my pattern, I'm multiplying by -3x, -3x. So if I multiply by -3x, that's going to be -27 x to the 3rd power. Now, I know it doesn't tell us to write the general term, but I'm going to do it anyways so that you could see what's happening here. So n minus 1, n. And this right here, the n's will cancel out. So then I have this lovely thing right here. That is my derivative. Now, based off of this information right here, it tells us to express f prime as a rational function. So this is an irrational function right here. But remember that our form is 1 over 1 minus x, aka the sum. So thinking about that strategy right here, my first term, if I were to plug in 1, So negative 3 to the 1 minus 1 is 0. And then I'm going to have 1 minus 1, which is 0. So this just tells me that my first term is just going to be 1. Then my common ratio is going to be negative 3x. And the reason why it's negative 3x is because I can actually combine these since my exponents are the same. So now I have a sub 1, 1 minus r, that's going to be equal to 1 over 1 minus negative 3x, or 1 over 1 plus 3x. So this right here is my lovely rational function. Write the first four non-zero terms of the Maclaurin series for each of the x, and use the Maclaurin series for each of the x to write the third degree Taylor polynomial for that lovely thing. Three factorial is 6. All right. F of x is x minus 3 halves x squared plus 3x cubed. We're only going to be stopping here because it asks us for a third degree Taylor polynomial. So that's what we're going to be doing here. If I multiply x by everything, I'm going to get x plus x squared plus x to the third over 2. I'm not going to do anything with this x to the third over 6 because if I multiply that, I'm going to get x to the fourth, which I don't want. Then if I multiply negative 3 halves x squared, I'm going to get negative 3 halves x squared right here. Then I'm going to get negative 3 halves x to the third right here. And then I have this 3x cubed, which I'm going to multiply by 1. And that's basically it. So now if I add them, I'm going to get x. And then 1 minus 3 halves, 1 half x squared. And then this one right here, I'm going to get 1 minus 3, which is negative 2 over 2, which is negative 1. Negative 1 plus 3 is 2, so this is going to be 2x to the third power. So this right here is my third degree Taylor polynomial for g of x.